So last time we talked about working with two-dimensional nested lists and nested groups, and we also talked about the list comprehension and the try except statements in Python. In this sixth part of the introduction to programming by Adrian Yudusawa, we are going to be talking about how to read and write to the files and how to work with classes and objects, which is often referred to as OOP, object-oriented programming. Beginning with how to read and write to files in Python. So in Python we use a function known as open to open the files basically. And this function called open, it takes two parameters. The first parameter is the file name and the second parameter is the mode. The file name is the name of the file which you want to open, but more technically it's the path to the file you want to open. We'll see later what that means. The mode is specify how do you want to open this file. One of the modes is called R, which is read. It's a short for read. So you open your file in this mode if all you want to do is to read it. This read is also the default value. In case you don't specify any mode, it will use this mode by default. So it opens the file in read mode, which means if the file does not exist, it will throw an error. The second mode is called W, which is short for write. So as you might have suspected, this opens the file in write mode. So if the file doesn't exist, it will create it. If the file does exist, it will overwrite everything that was existing on that file. It means if you had a couple text, if you had some text on that file and you open your file in write mode, everything that was on that file will be deleted and we will write on that file like from zero. So a take home point is, if you want to just read a file, use the read mode. If you want to write on a file or to create a new file, use the write mode. Now you might want to append on the existing file without necessarily deleting everything that was on that file. So in that case you use the append mode. And append does exactly that. It appends on the existing text. So you preserve the existing text. Now the X mode is simply to create a new file. You cannot write on it. But oftentimes I don't find myself using X a lot because I can just simply use write, and if the file doesn't exist, we create it. Now the syntax for opening files is, first of all, when you open a file, you need to have some variable to be able to refer to that file you are opening. So in this case I say f is equal to open, the open function. We saw that open receives two things, the file name, or rather the path, and the mode. In this case the file name is myfile.txt and the mode is air. So for this to work, I have to have a file called myfile.txt inside the folder where this Python script I'm writing is located in. So if you don't have this file in the same folder with the Python file you are working in, it's going to throw an error because it will look for this file in that folder and it won't find it. Now after opening the file, we can read its content by doing f.println. This will basically print the first line in the file, and if you repeat this statement the second time, it will print the second line. Third time it will print the third line, and so on. If you want to read all the lines at once, you could simply add s here and say f.read lines, and basically what that will return is like a list of all the lines in that file. And it's a very good practice to close a file once you have opened it. Now I mentioned that if you want to read two lines, you can write f.println 2 times, but what if you want to read 1000 lines? You clearly don't want to be writing 1000 lines of code. Instead, you can loop through the file, basically looping through all the lines. In this statement I said, for line in f, print line. This will simply go through all the lines in the file and it will print all of them one by one. And then I close the file. The next thing you want to practice is how to write to the files, because now you know how to open, you also need to know how to write to the files. So again, we open the file with open function, but notice that this time we opened it in write mode. So this tells Python that we are going to be writing on this file. Again, if the file exists, we open it and we get rid of anything that was on it before, and we write on it like fresh text. If the file was not existing in the current folder, and by the current folder I mean the folder where this Python script is located, then we will create this new file called myfile.txt. Now this is where we get to write on our file. f.write, so .write method is used to write on the text. I'm writing this, and then when you call f.write, you pass in the statement you want to be writing, or the line you want to be writing. So I passed in you are now writing to this file. This means this program will have a file called myfile.txt which has this file written inside it, and then I close that file. A quick demonstration, I guess, will help us. I have a file here which I have used a lot, but I won't be showing the files created. You can check for yourself, but simply we say f is equal to open. We need to pass in two things. F is equal to open. This function receives two things. Here we pass in the file name, and here we pass in the mode. The mode is always right, and the file name here is some file.txt. So this would create a new file in case it doesn't exist, called some file.txt in the current folder where this Python script is located. Then once we have opened the file, we can do f.write, and we can write some cool text. So this will write one line on the file. If you want to write more than one line, I can use \n, which means take a new line, and I can write some second line, and I can again use \n to write another line, another third line. But what if I want to write so many lines? I don't want to be doing this for like 1,000 times or 1,000,000 times. Instead, I can use a loop, maybe say like for num in range 1,000, maybe I want to write 1,000 lines, and then I will do f.write, and I can write whatever I want. It will be written 1,000 times. That means 1,000 lines, but to have 1,000 lines I have to write some text, and then I do \n. This means write this statement, then end the line or take the next line, and do that 1,000 times. So this would create a file with this name, and it will write this statement 1,000 times that file. Okay, I guess that's enough for now. Now, as I had just mentioned, another thing you could want to do is to check whether a file exists. Now, to check whether a file exists, you need to have some access to the operating system. But you basically, in Python, we basically use this OS model. We import it. I know you might not be familiar with importing, but it's the topic of next part, so I invite you to watch the next part. So basically you import OS, and then simply type this syntax os.path.exist, and you put in the file name. What this will basically do is to check whether you have this file test.txt inside your current working directory or your current folder. And again, the current folder means the folder where your Python script is located in. So if this file exists, this statement will return true. the file exists, this line will return true, and we can print something like, okay, file found. If it doesn't exist, then we return file not found. The reason why this might be important is you might be writing a software which at some points needs to open some files, but it's possible that the user might simply have moved that file or deleted it, and if you don't put this check, it's very possible that your program will crash as it tries to open a file which doesn't exist. So you could check whether a file exists. If it doesn't exist, you can return a useful message or tell your program how to behave. So again, you can also delete the file simply by using os.remove, and you specify the file. Now the next thing I want to touch about is how to navigate into other folders. So suppose you were in some folder, maybe I was in my current folder, and I want to access a file which is certain levels down into other folders. For example, I'm in a folder. Inside the folder I'm working in, there is another folder called folder 1. Inside folder 1 there is some other folder. This is a mistake here, and inside that other folder is where my file is located. If I wanted to access this file, I basically need to write a dot backslash, and I write all the path to the file I want. So this will look all the way down to that file. In the same way, if I want to navigate upward, maybe I was deep inside this folder and I want to navigate backward. So maybe suppose my Python file was here in some folder. Suppose my Python file was in this folder, and I wanted to read the file which is in this parent folder. So I could use double dots, which means go up one time, then I will do what I want to do. So the double dots goes backward one folder or one directory. The dot slash, as you enter the folders, you can go deep, and here you can go backward up. So I could do double dot slash, and I can go upward as much as you want, and you can also go deep as much as you want. So this is how you navigate across the directories or folders. Now for the second part, we're going to talk about OOP, which is object-oriented programming. So basically OOP, it allows us to write the clear modular code. It allows us to write very structured programs. And the reason why this is good is we want to be able to reuse the code, and we also want to be able to really, if you want to write a very complex code, it's very good that we be able to write some pieces of code and store them in a very structured manner, and then use them when we need them, and also be able to reuse them in other programs. We haven't seen how to work with models, but I apologize, my Google AI is trying to guess what I want. But I was talking about the models. We want to be able to write our code in such a way that we can reuse it in other programs or in other sections of our program. It also allows us to define abstract data types. Now this might be hard for you to understand at this point, but imagine if I was creating a game, and my game needed to use some persons who are maybe running or playing a game. So these persons, every person needs to have some behaviors. A person has a head, I would have to say, okay, this person's hair will be this long, he will be this tall or this, or he will have this height or this weight, something like that. Or he will be wearing white or black clothes or red or blue, something like that. Now all those properties, it's hard to store them in the traditional data types like the string or array or set or hash map, which is a dictionary in Python. Now because of that, you could define your own data structure which represent a human, and your data structure you could make it in such a way that it can store all this data you need to store in a very clear way, which we will see in a very near future. So in OOP we have the two major words, class and objects. A class is basically a blueprint that we use to create objects. As in this example, you can see we have a blueprint of a car, and then we can create multiple instances of the car. This is a Mercedes car, a BMW car, Audi car. They are all cars, but with slight different modifications. So the class is a blueprint. The object is an instance of the class. And the way we create classes in Python is we simply use the keyword class. We put the name of the class, and the class we have some methods and some properties. Now the full syntax of creating a class needs a method called the constructor. And the constructor in Python is defined as you define underscore init. Again, these are two underscores. I can't stress this enough for my students because they always forget and they write one underscore. These are two underscores, underscore init, underscore, and it's a function, but which is a built-in function in Python. It's called the constructor, and the reason why it's a constructor is the function which is called every time we create an instance of this class. So this is a function Python comes looking at when it's creating an instance of a class. So another new thing you need to be familiar with is when we create a class can contain properties, which are really variables, and the methods. If I was creating that car, which we saw here, the properties would be like color equal to gray, number of tires equal to 4, for example, we could say has chairs, blah 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 blah. Those are the properties, the features of this car. And the methods would be like the behaviors of this car. The car can honk, it can start an engine, it can shine right, it can drive, it can do blah 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 blah. So the methods define the behaviors and the properties define just the properties. Yeah. So the reason why we need the constructor method is to be able to create these different versions of a class. You see, this person needs to create a class but with a green color. So in our constructor method we accept some parameters, some arguments. Here we are receiving name and age, and we can color our car with those new arguments. For example, we can set self.name to the name which we received, self.age to the age we received, which means I can create several instances of human class, and I can pass in different names and different ages. Person 1 is an instance. This is how we create an instance. You simply refer to the class name, which is like our blueprint, human, parentheses, and you pass in whatever variables you said you would be accepting inside your constructor. So my constructor accepts name and age, that's why I'm passing in a name and an age. And my constructor will set self.name equal to name and self.age equal to age. And we will see what this self does. So simply, all the classes you make, it's a good practice to it's very necessary that you add the constructor method, and this is a method which is called when an instance of the class is called. We use to accept and to set the initial values of class properties, and really it's the only function that you are expected to always have in your classes. Other functions you can add whatever you need, but this is the common one in all the classes. Now, what are methods vs properties? If I'm creating a class for a cat, the behaviors or the methods would be something like sleep, drink milk, something really which the class does or the object does. For the properties, it's more of features like legs, forelegs, eyes, two eyes, something like that. Now all the functions or methods inside the class, they receive self as their first argument always. The reason why this is important is when we accept self, we have access to the this object, like this very object which contains some variables. Remember that when we were working with functions originally, we could not, for example, access a variable which is outside the function. But with a class, if we have our variables here, our properties here, inside all the methods, we could access them by saying self.regs, which give us this variable, or self.ice, which give us this variable. The reason why you can do that is because inside this function we are passing in self, which is pointing to the first memory address of this object inside memory. So it simply gives us access to all the methods and all the properties of this class. In the same way, remember, if when we're writing functions, we could not call a function before we initialize it. But I haven't done it here, but you could try it yourself. Inside this function strip, I could actually call drink milk, even though it seems to be defined at a later stage, but it would work. For example, I said self.drinkMilk inside this method. It will be able to run it here. The reason why it's able to do it is because of this self, because this will give me access to the memory location of this class, and it will have access to all the methods inside itself. Okay. Now, how do we access the methods and properties inside the class? I made an example here of a class called students. I gave it a constructor method which receives name, birth year, and hobbies. Self is like the default, all the functions have to have it. Now when we receive a name, we save it as a name. Birth year, we save it as born, and the hobbies, we save them to hobbies. So when this person create an instance called Paul, create an instance of student with a name Paul, and the birth year pass in 2010, and the hobbies pass in this list of all his hobbies. Now when we create this instance of student called Paul, now Paul has all these properties and all these methods. And the way we can check that is we can say Paul.name. That will give us his name, which is Paul. And we say Paul.hobbies to return those hobbies, that list of his hobbies. Now Paul.findAge, because this is a function, it's a method, we need to invoke it by using double brackets, as you might be very familiar with at this point. Paul.likes football. By the way, find age, it simply takes 2020 and it subtracts self.born, and this is what I was talking about. Notice that this self.born is not defined inside, we didn't define this variable inside this function, but we are still able to access it because it's a part of the class. So when we say self.born, self means, okay, check inside this very object we are in and check for its property called born, and it will be able to access it, and it will return 10, which is 2020 minus 2010. Now this one says likes football. It's a method which simply checks whether a person likes football, and the way it checks that is checking in the list of hobbies, and we check whether there is a word football. So if that word is in hobbies, and we return true, otherwise false. In this case, this person just likes singing and dancing, so there is no football, we return false. And we see more about object-oriented programming in the next week. And here I have a very good practice problem. Imagine you are working in I won't be reading it basically because everyone understands English, and this is basically one practice problem for you guys to try. And there's another homework problem. This is working with some DNA sequences which you can really download online. I believe you can simply find it online. And then as a review, we looked at reading and writing to the files, classes and objects, which we finish next time. So for these problems, if you can't find these files, or you can't create your own file in this way, or you can't find this genome, simply let me know in the comment section, and you can send me your email or your Instagram or anything you use, and I will be glad to share with you these files to work with. So thank you for completing the 6th week of the programming class, and I look forward to seeing you in the 7th week, which is the second last part of this course. And congratulations for coming all the way this far. Thank you. Like the video and share with your friends if you think it helped you, and then let me know so that I can know what to improve on. If you see an error or a mistake in my videos, always feel free to let me know. I am also human and I make a lot of mistakes, and I'm ready to fix it next time.